right? Okay, so yeah, the science, right? So I see that yeah, I would yeah, we're now looking at the same thing, right? This is the Debbie grew some seeds question. Okay. Okay, so Debbie wanted to confirm if germination will require light and warmth. Which set of traits should she compare in her investigation? So we want to check. Wait, what do we want to find? Germination require light and warmth. So light and warmth. Is it no. So it's just the requirements for germination, right? Is your air, warmth, and water. Yeah, yeah. So anyway, because they want to check, they want to check whether it needs light or not. So one of the ways that she can do in her experiment, let me see, which sets should we compare? So answer is 3 x z. Okay, x z, because xz, so if you look at xz, right, this one has light, this one is no light, and the rest are almost the same, present and warm. So this can be used to check light. Okay, so this xz is used to check light, that's correct. Then for the warmth is wz. So wz, okay, use another color. So wz is just this one, no and yes, correct. So then the rest are the same, you see, it's no. Yeah, so what I mean, now I'm curious, like what was her option for this one? What was she confused with? Oh, is it because of this, the word light, is it, that you got confused? I'm sorry. Okay, option one. That means her original option was option one. Oh, like don't know how to proceed lah. Okay, no worry. Now let me explain how to proceed for this type of question. Now for this type of questions, what we do is we want to make sure we eliminate what is not necessary, because in this question they specifically say they want to test whether light is required and warmth is required. So if you are testing for light, light will be different. You just need to make sure that light, as seen in the blue color, there is one yes, one no. Then the rest is the same. The rest is the same. So this is the variable, the change, which variable you want to change. Yeah, so that's the part that you have to you have to look at. You can do that. Okay. Yeah. Okay, then the other one is just the warmth. So for warmth, you make sure that warmth is different. Warmth is different. Yeah, then the rest is the same. Then the rest is the same. Now here we have a variable that's a bit weird. That is the average length of root. Right? So can you see that on the last column here, you got the average length of root, which is like a bit not necessary. Yeah, not necessary. Yeah, it's not necessary in this particular question, so we don't care about that. Okay. That's all. Yeah, that's all for this one. Any other question for this? Okay, next. Right, so we have a classification table as shown below. Group A3, ink from a pen. Which of the following shows the correct heading? 2. Matter, non-matter. Heat. Oh, okay, so her original option was 4, is it? Definite volume, no definite volume. Definite volume, ink, a metal ruler, apple, tree, no definite volume, heat, sound, shadow. Okay, this is very, very, very subjective, this particular question. You see, from the first part, right, you can see that actually there are two options. That means 4 and 3. They both look okay, right? Sorry, not 4, 3. 4, 2. Yeah, 4, 2. 2. Okay, so they both look okay, you look at this, right? These are all matter. So matter, what's matter? Solid, liquid, and gas. Right? All matter is solid, liquid, and gas. And this one is non-matter because it's heat, sound, shadow, right? So, and then after that, now that you have narrowed down to either 2 and 4, we look at the options. So this one is definite volume. This one is no definite volume. But you must remember, no definite volume is a description for matter, right? And specifically, which matter don't have definite volume? Which matter don't have definite volume? Do you remember?
Yes.
Yeah, gas. Right? Gas don't have definite volume, right? Can you see that?
Yeah.
So the problem now is that these are not matter at all. Group B, they are not even matter to begin with.
They are not matter. Okay.
Yeah, but the description of has no definite volume is to describe matter.
I see. Okay.
Can you see that? So here is a case of which is a better answer. Okay, so sometimes you got to prioritize like which one is a better answer? Is it option 2 or option 4?
Yeah, option 2.
Yeah, option 2 is the better answer. I know, I understand that if I was doing very fast or if she was doing very fast, and if she didn't look at the other options, right? Option 4 would look like an answer, correct? Like option 4 is like an answer, but you gotta go deeper lah, and to understand that the word volume, definite volume is used to describe matter. So in this case, these are non-matter.
Oh, okay.
Yeah, the stuff in group B, they are not matter at all, so there's no need to use a definite volume, to try and to describe group B, items in group B.
Okay, can.
Yeah, that's all. Right, next one.
Yeah,
Next. Okay, so Megan conduct experiment, how mass affected friction. Okay, so here we have which of the following is true? So the length compressed spring decreases, distance moved increases. Okay, so it said for the amount of friction acting on A and D was the same. A and D, amount of friction. Okay, we cannot tell. You see, you chose option 4, right? Yeah, option 4 says the amount of friction was the same. But how can you tell that it's the same?
A and D, because they move the same distance.
Yeah, but then the compression is different, right? You see here is 8, this is 4. This is being compressed more. This one compressed less, right? Yeah, so the amount of force pushing the block is different. So you cannot say that the amount of friction is the same.
Oh, because the force is different.
Yeah, the force is different. Pushing the block is different.
Oh, okay.
Yeah, so usually this time, what we do is we look at all the options. 1, 2, 3, 4. Let's look at option 1. So block C was the lightest in mass. Block C was the lightest in mass. We can try and deduce and see. So we move the furthest with the least compression. Length of compression, correct? With the least compression. When it's 8 cm, it shows that they didn't compress a lot. Okay, 4 cm means they compress a lot. So least compression, move the longest, the furthest.
Okay.
So this one is true. Okay, this are question we will eliminate, right? So block A was the heaviest in mass. You see, A compressed 8, move 12. This one compressed 4, move 12. So this one is false. This statement is false. Are we okay? Are you following my reasoning? Yeah. So 3, there was more gravity acting on B. This is definitely wrong. What's wrong? What's wrong with this? Without checking the table, right, I know this is wrong. How come? Because of this, there was more gravity acting on it. Alright, so this is wrong because gravity is the same for every block.
Every block.
Yeah. The amount of gravity acting on the blocks are the same. So there wasn't more gravity.
It's only when the block has the same mass, right?
At the same one, sorry.
Have the same mass, they weigh the same.
And then. Okay, so this is the gravitational force, acting on the block. The gravitational force acting on the block is the same. The weight are different, but then they have the same pool of gravity. Gravitational force pooling is the same.
Yeah, so this one is wrong.
Yeah, this is wrong. And so of course, once again, you have between 1 and 4, right? 1 and 4. The amount of friction. So the last one we also cannot tell. We cannot tell whether this is true. So it's just option 1.
Yeah, option 1. Okay.
Yeah. Okay, next.
Okay.
Okay, next, we look at this. So what would most likely observe for steel bars A, B, C, D? So A, B, C, D. I have north here. Oh, okay. Okay, so another steel bar was magnetized as shown. So they magnetize this thing, right? What would most likely observe for steel bars A, B, and C, D? Steel bar AB attract to magnet. CD attract to magnet. Wait, what did they do to CD? Right, so they turn the magnet, right?
Yeah.
In diagram 3, they turn the magnet and they did the magnetize. Okay, so what does this show? What does this show, right? You know diagram 2?
Diagram 2.
Yeah.
The compass is
this one north.
Pointing north.
Correct. This north.
Pointing north and B.
This one is south. Correct. That means here is south. This one is north.
Oh.
Is that right? So your deduction is correct. Here is north. This one is south. Okay, because the black color, you see the black color compass, the black color part, right, is the north.
Yeah.
So the north will point this one, right?
So the north is pointing to the south.
Attracted is attracted. Yeah, it's pointing to north because north is this direction, ma. You see, north is this direction. So this compass always point direction. So it's pointing north is this direction, south is backwards. You see that?
Okay.
So this diagram tells us that A is north and B is south.
Yeah, okay.
Right? So what this means is that if I were to use the other end, right, to do the magnetic this induction stroking method, here I should get north and this one should be south. Okay, so let's take a look. So the magnet
is actually diagram 1 and 2, they are the same, right?
Yeah, same. They tell you the same info. That is, one is north, the other one is south.
Okay.
Yeah, so let's see what we have here. What would be observed for steel bar A, B, C, D? So you chose 2. Attract to magnet. Yep. Then attract to magnet. Because C is south. Wait, repel by magnet.
C should be south.
C should be south. So this one is correct. North, south here. So these 2.
North, south. The C is wrong.
Yeah. So it should be, because here is north, ma. Sorry, this is south. Let's see, the C is south. As shown here.
Yeah.
So this should be south, and this is south, right?
Oh. Yeah.
Because it's north, so this one should repel.
Repel.
Yeah. So my option is 2.
2.
Yeah, that's right. Is it okay? Is that what?
Okay.
What did she put 1? Is it?
The answer is 1.
The answer is 1. Attract to magnet. How come? CD. Magnetize using a magnet shown. CD. North, south. North, south. But this should be south, right? Why is it?
Which one?
Yeah, here it should be south, right? Then after that, yeah, I mean in diagram number 3, this is the this is the reverse of this, right? 3 is like the reverse of 1, so you're gonna wait. Let me see. You do north like this. You do south, south, north, right? So you should get C, D. Then this C is south, right? Yeah, it should be repelled, right? Yeah, I mean, I get 2. That.
Okay, so it should be 2. It should be 2.
Yeah, I get 2. I got option 2.
Okay.
Okay, let's see the other one. Number of days in which each stage of the life cycle of insect. Okay, R and S. Okay, so at which stage would insect R and S be on the 29th? Is it 20th or 29th? Day 20th day. 20th day. So you gotta count 20th day after the eggs hatch. So the eggs hatch. Okay, so for example, we look at R. So R takes 12 days to become as an egg. Then 12 days later, 14. This is 14, right? 4, 8, 12. Yeah, so here is 14. 14 days. This is 12. So on the 20th day, R is a larva, isn't it? 4. Is this 20th, is it?
Yes, 20th.
20, Yeah, so 20th day after the eggs hatch. So you see this, so you start counting from the larva stage. We start counting from the larva stage because they are talking about after the eggs hatch. So yeah, so this is 18. That means R on the 20th day, 14 is here lah. R is over here. Is it R is over here on the 20th day?
So this.
Do you know why R is here on the 20th day?
This one is 16.
16. Oh, okay, doesn't matter. It's still there. 16. R is still here.
So
On the 20th day, R is here.
R is here.
Yeah. Do you know why?
Don't know.
Okay, so you see the question is after the eggs hatch. You see, it takes 12 days for the egg to hatch. Then you start counting 20 from here. That means from here. You don't start from here. You start from here. Right?
Start from lava.
Correct. Start from larva. You start from the larva. So larva will be 14 days, right?
Yeah.
14 days, 20th day will be here.
Oh.
It's on the other side.
Oh, okay.
Yep. Then if you look at the insect S, so insect S is here is 4 days. Then this is 6, right? And this is 12. This is 10. Is it 10?
10. Yeah, 10 days.
And the other one is 10 as well.
10.
Yep. So we gotta start counting from here. We start counting from larva stage again. So 6 plus 10, 16. So 6 plus 10. So plus 4 more, so adult. So S is here.
Oh.
Yeah. I think the tricky part is they asked about it starting after the eggs hatch. After the eggs, that means we don't count the numbers here. Here we don't care.
Okay.
We don't care about them being an egg, right? We want to start after the eggs hatch. That means you start from
Okay.
larva.
Yeah, after the egg.
You start.
Correct.
Start from the larva stage.
Okay.
Okay, next. Okay, how do bacteria reproduce? They multiply. Multiply. Okay. Oops. Right, it's not by spores. They just multiply. No bacteria multiply, like something like cell division type. So it's not by spores. Bacteria is not by spores. It's not algae. Only algae. You know algae?
Algae is by
Spores.
Algae is by spores.
Yeah, fungi. Right? Mushroom. Right, all these are spores.
Oh, okay.
Okay, so this bacteria is not.
Okay.
Yeah, bacteria is multiply. They multiply. Yeah.
Okay.
Next. Okay, the table shows the characteristics of 3 different plants A, B, C. Okay, flower. Can the flower develop into fruit? Okay, so the flower of plant B cannot develop into a fruit. Give a reason why. Can the flower develop into a fruit?
Sorry?
Okay, wait. I'm reading this one. So can I check? Is this your answer? And then this one is the correct answer.
That is the answer, but the answer provided is below.
Okay, wait. Let me see. It's really hard to see. The flower of plant B has not been pollinated as so the ovary will not turn into fruit. Plant B is probably a small male plant that does not have an ovary and ovules to grow. Plant B, the male plant. Oh, okay. Okay, so here there are. Okay, your answer is that the flower has not been pollinated. But the question is not about pollination. They're saying that even if there are like bees and butterflies that does the pollination, this bee will not develop into a fruit, even though there are insects that can do pollination. But no matter what happens, this flower, why is it that this flower will not become a fruit? Yeah, so there are some flowers that are purely like the male type. You know what I mean? That means they only consist of the male reproductive systems of a flower, so it doesn't have the female.
But is it a male flower or is it a male plant?
Male, wait, this one is talking about what? A male plant. I think they are referring to the fact that it's just male. That means the that particular flower is a male flower.
We can say it's a male flower, right?
Yeah, it's a male, or the flower has, to be more precise, you just say the flower has only male reproductive the parts.
Oh.
Yeah, so it does not have an ovary. You see, it does not have an ovary and ovule, so it cannot grow into a fruit.
Oh, okay.
It cannot grow. Yeah, so here they are not asking you why didn't it grow into a fruit. You know, here you see, can the flower develop into a fruit? Is no, it cannot develop into a fruit. That means this particular flower will never become a fruit.
Yeah, will never lah.
So they are not asking why didn't it become a fruit. You see the little difference there? It's it's a bit of the English word. You see, this one is can the flower develop? Is no, it will never be able to do that. You know. So your answer is why it didn't develop into a fruit.
Yeah, okay.
Yeah. So if the question was why didn't the flower, if they change this to why didn't the flower develop into a fruit, then your answer will be possible. It's a possible reason. But this is it cannot develop into a fruit. Do you understand? It's a very slight difference. You know,
Permanently cannot.
yeah, permanently, no matter no matter what it does, it will not develop into a fruit.
Oh, okay.
Okay, can?
Can.
Yeah. Okay, so next one. Flow charts. Okay. Okay, study the flow chart below. Is it sorry, what's this? Matter, is it? Matter.
Yeah, better.
Matter. No. Yes. Which one of the following represents this is? What's this word?
Steam.
Steam. Steam.
Yeah, steam.
Okay. So steam is matter. Yeah, steam is definitely matter. So does it have a definite shape? No. Does it have definite volume? No. Okay, so you chose, is it you chose this? Did you choose Y?
No, she chose Z.
She chose Z. Wait, let me see. Does it have
Answer.
steam? Okay,
Steam is liquid, right?
yeah. Because it's condensed, you see water vapor condensed to become steam.
Water droplet.
Yeah. So you can see the steam is because it has condensed. So water vapor is gas.
Water vapor gas. Yeah.
Yeah, this is gas. So condensed becomes steam means this is liquid. Okay. So does liquid have a definite volume?
Yes.
Yeah. So it's here lah. Yes.
It's Y, huh?
Ah.
Okay.
Yeah.
So the answer given is Z. Number 4.
Number 4. Z. Does it have a definite volume? No. Why does it not have a definite? But steam is liquid, you know. Steam is liquid.
Yeah, it is.
Steam is liquid, so liquid always have a definite volume.
Yeah.
Yeah. I mean that's my understanding. Water vapor is a gas. The hot water vapor condense becomes steam when it touches the cool surface in the environment.
Yeah.
Yeah, also
The answer should be 3, yeah.
yeah, I will still go with this one. Y.
1. Okay.
Yep. Okay, next.
Next one.
Position under the green P as shown. Which part X, Y, Z provides the seed with energy to germinate? Part Y.
The answer is part Y.
Part Y. So here
What is part Y?
isn't that the seed code?
Huh?
Is it a seed code?
X is what? If.
This one, okay, this is a bit, it's a bit hard to tell, you know. Usually they like merge the whole thing together. Okay, but in this particular question, they separated this thing. X is probably like the black color coating.
Yeah.
The black coating. You know, some seeds after a while they have a black coating, right?
Like a bean sprout or.
Yeah, the black color coating part doesn't provide the energy. Is the inside, the inside.
Or the inside.
Yeah, so I think this question is just referring to the inside, not the outside. Yeah,
Then the Z is the.
very vague a bit
Z is the what? Z.
I think it's just like the outer covering.
Z is it the shoot or?
No. Z. Oh, Z lah. Z I think is the root. Root.
It's the root.
Because a root comes out first.
Oh, okay.
Yeah, the shoot doesn't come out. Only the root comes out first. right? So this has got to be the root, and the this X, right, is like the extra black color coating. Then the I mean the energy is inside, like inside the seed. Yeah. So don't worry. I mean, some of these questions are very how should I put it? It's very ambiguous, right? Some like you don't exactly know what they're talking about. Some of them you gotta give it your best guess. I think it's one of them.
Okay.
Yeah, because in the P6 syllabus, you don't really study like, how exactly does the seed look like. They don't dissect the seed into so many parts. Yeah, they only have the root, the shoot, and the seed leaves. They call it the seed leaves, right? That gives it the energy for germination. Yeah, this one never mind. I think can ignore this.
Okay.
Yeah. Next.
Next one. This one.
Okay, both trees were planted at the same time. After several months, tree X had many, but tree Y had none. All have no ovaries. Uh, okay, so let's do some elimination, right?
Yeah.
Okay, all the flowers on tree Y have no ovaries and stigma. Okay, this is a possibility, so that's why there are no fruits, because for you to have fruits, you need to have the flowers with ovaries, right?
So this one is the male flowers.
Yeah, all the male flowers.
Male flowers.
Yeah, so eggs have undergone cell pollination. So eggs cell, yeah, after pollination you get the fruits. Next one, the flowers on tree Y were not as sweet smelling as the ones in X. The ones in Y were not as sweet smelling as the ones in X. So no pollination. Wait, a new organism was introduced to prey on the pollinators in the garden. So no pollination. Pollinators in the garden. Okay, why did we eliminate this? The flowers on tree Y were not as sweet smelling. Okay, fruits. There are no fruits. Which of the following below explain? X had many papaya fruits. So for tree X to have a lot of papaya fruits, they definitely needs to have flowers, and then after that they have to be pollinated to become fruits. So pollination occur here. Over here, no pollination. Not as sweet smelling. This is a tough one, though, this question. Yeah. See, not as sweet smelling. Okay, I think another thing we can do is we can look at like our options. You see, so here is A, B is confirmed, right? Yeah, I mean I would choose A and B.
Self-pollination is.
That means the plant itself, the papaya tree itself, right, has got male and female. Male plus female flowers.
Male plus female flower within one flower, is it?
Yeah, within one plant.
Within one.
Within the plant itself.
Within the plant.
Yeah, so within the plant it has male and female.
Flower.
Or it could be within the same plant. Oh, okay, I know what's going on. So you see, in this case, right, this particular species, right, papaya, is possible to have male and female within itself, right? So because of that, it is able to pollinate even without having this this thing and this thing happening. Is it? Yeah, that means the fact that these three eggs, right? These are in a garden. They're in the same place. They're in the same place, right? They're in the same place. That means the amount of if there was a prey, if there was a new organism that to prey on the pollinators, right? It will affect eggs as well. Do you understand what I'm saying?
Yeah.
So, but eggs wasn't affected. What? That means that it shouldn't be like this.
Oh, so it's able to self-pollinate.
Yeah. Then this one, the flowers on Y were not as sweet smelling, but they were in the same place. You know what I mean? Because of the fact that they're in the same location.
Yeah.
Yeah. So it's a bit hard to explain as well. Anyway, C is a bit hard to explain. So anyway, if we see that A and B are the correct options, right? We can use elimination for the answers, right? So for example, 1 wouldn't be true. You wouldn't have to choose 1 because there's A and B. So option 3 don't have A, so we don't care. Then option 4 don't have A as well.
Don't have A, yeah.
Yeah, so only left 2.
Okay.
Yeah, use this type of elimination.
Okay.
Yeah, a bit hard to really hard to explain this one. Answers. Yeah. Next. Okay. Okay, so after 15 minutes, both the mass and volume. Okay, this is tricky, this one. Because of the word mass and volume. Mass increase means that air must go in. Air must enter. Because the mass increase, so air must enter the balloon. Right?
Okay.
So let's look at the options, right? To see which one has got air going in. Okay.
Air going in only affect the mass.
Yeah, air must enter the balloon.
Then what about the volume?
The volume, when air never go in, the volume can also increase. Right? So we look at the options. So water at 100 degrees Celsius. Okay, so in this case, first scenario, this one, the volume increase. Okay, why does volume increase? Because water is 100 degrees Celsius, right? But did the mass increase? The mass remain the same. Right? Do you know why the mass for this one? Why the mass remain the same? The mass of the air in the balloon remain the volume. Yeah. The volume increase. This part is it okay? When we say volume increase.
So why the volume increase?
Okay, because the temperature is 100 degrees Celsius, so the balloon will become bigger, expand. Right? Balloon expand. But the mass remain the same. How come? Because the whole thing is tight, so air cannot go in. There's no new air going in, so no air goes in. Right? No air goes in, so the mass remains the same.
Oh, okay.
Alright, so look at option 2. So this one, okay, for this one, the balloon volume increase. Right? Why? Because water is 100 degrees Celsius, so the air expand here, and it went into the balloon, so the balloon will increase in size, right? So the volume increase. Now the mass also increase. Okay, why did the mass increase here?
Because air.
Yeah, air has went in. There's new air going in. Yeah, you compare to this, there's no air going in. Only the volume became bigger. Okay, here, different. In the balloon, the air went inside. Alright? So far, is it okay, this one?
Oh, okay.
Between these two, is it alright?
Yeah, alright.
Can. Okay, next one. So setup C. Balloon inside empty bottle with opening wrap. Okay. So in this case, so here is cold, means air went in here, right? Because here cold, here very cold. When it's very cold, what happens to the volume here in the bottle? The volume in the bottle.
The air can went in.
Yeah, because okay.
I thought the opening is the wrap tightly.
With its opening wrapped tightly around the mouth of a balloon inside an empty bottle with its opening wrapped tightly around the mouth of the bottle. It's around the mouth. That means like here. I don't think they close the bottle. That means, yeah, that means air can still go inside. Is it around the mouth? So it's around. I don't think they close this one.
Oh, so they like put the balloon, then they
Close
press
the.
down.
Yeah, they press down, so air can enter into the balloon. You know, so I think what's happening here is that because it is cold, and the air here, because it is cold, right? So the air here contract. Then when the volume decrease, air will get sucked inside. When the volume of the air in, okay, let me use, let me explain one more time. Start from beginning. So this is, let me type it here. So volume of air in bottle decrease, right? First sentence, is it okay? The volume of air in bottle decrease.
Volume of air in bottle decrease because of the
cold, the ice.
Coldness contract.
Contract.
The air contract.
Correct. Then air gets sucked into the balloon.
Oh.
Right, because of that. So.
Because there are more space, is it?
No, it to take up the space.
Oh.
To take up the space in the bottle.
In the bottle.
Yeah, because the volume of air decrease.
Yeah, okay.
Alright. So after that, what happens is that the volume of balloon increase, and the mass of balloon increase also. Is it okay? This is a bit tricky.
Yeah. The volume of balloon increase.
Yeah, because when air goes in, this thing will increase in size.
Oh, yeah.
Right? Right, so this.
Okay.
Yeah, so the volume will increase. The mass also increase because new air went inside.
Oh, okay.
Yeah. So this is different. This one no need to say because air going out. This hot water, so air is moving out. So we don't need to.
Air moving out, okay.
Yeah, so this is not correct. This one also not correct.
Yeah. The volume is
to BC. Yeah. So sorry, you were saying?
for D.
Why D is wrong, is it?
Yeah.
Okay, because the hot water caused the volume of air in the bottle to increase. Right, volume of air in the bottle increase.
Volume of air in the bottle increase.
Yeah, so air is pushed out of balloon. air is being pushed out of the balloon. So volume of balloon decrease.
Okay.
Mass
also decrease.
Yeah, that's it. Right, so what are we looking for? We're looking out for both increase. Right, so we want both mass and volume to increase. So the only one with both mass volume increase is B and C.
B and C.
Yeah.
Oh.
Only B and C. Alright.
Okay.
Can. You got any other question on this? Can ask me.
No. Okay.
Can understand. Okay. Next one. Okay, let me take a look first. Okay, so we have at 4 different locations. P is in a sunny field, R is in the air condition. P is sunny field, R is in the air condition. Okay, so we have to do elimination here. We gotta look at it one by one. You cannot deduce just by looking at this. But what we can tell is that S evaporate the most, right? I mean the water in S evaporate the fastest, not the most, the fastest. Yeah. So the exposed surface area in P is more than Q. The exposed surface area in P is more than Q. We cannot tell. What's wrong with this statement? They say that the exposed surface area in P is more than Q. We cannot tell because they are all identical, right?
Identical.
So cannot be this,
Okay. Because the container all identical.
Same. They're all the same.
No, it's not correct.
This is not correct. So we look at 2. There is less water in S than P. This is not true also. Why? Because they all start from the same amount. See, this is the same amount, right? So they all start from the same amount. Next one, there is less wind at the location where R is than the location where Q is.
Less wind.
Cannot be.
Same location.
No, different location. But R is faster than Q. So there should be more wind. This word should be more.
Yeah.
This one should be more, right? This word is wrong. This one wrong, huh? So is this one, no? Last option. Right? P is placed in a sunny field. R is in an aircon room. Because sunny field will evaporate faster than aircon room.
Yeah. Okay.
That's it. You gotta use elimination.
Okay.
Yeah, one by one. It's very tedious, all these MCQ. They are like testing your IQ.
Yeah.
Yeah, sometimes I find that it's not so much of science facts, it's more like your elimination procedure, your technique, your MCQ technique. Yeah. Okay, let's take a look at this. Around the brightest bulb. So which bulb would Suling most likely find E hovering over? B, bulb B. Okay, this one, let's see. So parallel. Okay, so let's examine one by one, right? So we want to find the the brightest one. Now how much battery power will each one of these get? Let's look at option A, circuit P. How much battery power will each one get? What we do is we see that there are two batteries, right? There are two batteries here.
2 divided by 3.
Correct. 2 divided by 3. So this is like 2 out. Oh, sorry. Here, 2 out of 3 batteries. Okay. This one get 2 out of 3 batteries.
Yeah.
Next, option B. Now this is this is a bit hard to see. It's actually parallel.
But this one is parallel. It's a bit weird, huh? Diagonal.
Yeah. If we were to redraw, it looks like that. Let me redraw the thing.
Oh, it's actually
Parallel. It's parallel. You see like that. Then this one come back here, and in the middle you have wait. There are three parallel. This, and then you got another one like that. So your B is here.
3 parallel.
Yeah. 3. B is the last one. Over here. Why? Okay, how can we tell? Because you see, when imagine your electric current moving here, right? When you reach this part, you have to split into 3. You split into path 1. So this is one path, second path, third path. 3 lines. You see, when you reach this part, electron come here, must go 3 lines, right?
Yeah.
So there's like three loops. 1 loop, 2 loop, 3 loop.
Oh, okay.
Okay, so what happens in this type of circuit is that each one will get 2 battery power. Okay, bulb B will get the full power of 2 batteries. Is that okay, this one?
No.
No, okay. Okay, because this is series, look at this, this is series. So you divide by 3. 2 battery, you divide by 3. So each one gets 2/3 of a battery.
Oh, okay. Oh, so this one is parallel.
This one parallel. So each one
parallel will get 2 battery.
2 battery. Power is 2 battery. So here this is parallel, but then the 2 battery power, right, divide by 2. So each one is only 1 battery power. Right? This one also 1 battery.
Okay.
So not so powerful. Next one. Okay, now here this is parallel again, but then D also only get 1 battery power, the power of 1 battery. Because because you see 2 power here, but they divide by 2, so this guy gets 1 battery.
Oh, okay.
Yeah, so now you want to see which one is the brightest. It's the one with 2 battery. This one.
2 battery,
Yeah. That's it. So it's B.
Oh. Okay.
Brightest. Yep. Okay. Is this okay?
Yeah, okay.
Can next one.
This one is actually
Part C.
this question, part C.
Okay. The reading for material after the power supply switch off. Is this 100? This is 100, is it?
Yes.
Number of coils, 100. So one is 1, the other is 2.
The other one is 3.
Oh, 3. This is 3. Which material PQ is more suitable to use the electromagnet? Okay, so reading on the balance. Okay, we want the spring balance. Okay, if it's an electromagnet, that means it will attract. So the reading on the spring balance, the lesser the better. P. It does not exert a force of attraction. once it is switched off. Wait, so the lesser the better.
The lesser.
That means the number, we should choose P, right? P is the correct option to choose. It's more suitable.
Yeah, the answer is P, yeah, correct.
Yeah, P is correct. But it does not exert a force of. Are you asking me why is it P?
Yeah.
Why is it P?
We don't understand the.
Oh, why is it P? Is it?
Relation.
Okay. So now you see here you want to use as an electromagnet, right? What is the purpose of an electromagnet? It is to, for example, if this is a, let me just show an example, right? So this is a vehicle, you know, in those scrapyard, then you get an electromagnet. Okay. Oh no. So this is supposed to attract, right?
Yeah.
Okay. So when you switch off, you want the vehicle to drop down. You know what I mean?
Yeah.
That means you want it to be powerful, but when you switch it off, you want it to let go. So to be a good electromagnet, it must attract and let go fast.
Oh.
So far, is it okay?
Yeah. Okay.
You must attract and let go fast. Now, if you look at Q, you see what happened to Q? Still 3, you know. They switch off the thing, but this thing still shows 3.
Oh.
That means it did attract, but it cannot let go. You see?
So there still be 3 stuck there.
Because
Oh.
yeah, it's still stuck there. It's still stuck.
I see. Okay.
So we don't want it to be like that. Okay, because we want it to attract and let go fast.
But is the explanation like a bit weird, right? So.
You mean this one?
Yeah. How can it prove on it? It does not exert a force of attraction.
It does not exert the force of attraction. Once I think they skip this explanation on the criteria for an electromagnet. So maybe you can add in to be used as an electromagnet. To be a suitable electromagnet, it must attract and let go of the magnetic material immediately. So P shows that it's able to let go immediately, whereas Q does not show that. That's all. Yeah. So why? Because it does not exert a force once it is switched off. Whereas Q still continues to exert a force. So you just have to talk about the criteria for an electromagnet.
Okay.
Yeah, the criteria is not explained here.
Okay.
Yeah, even though the option is correct, right?
Okay.
Okay, this is if there are air bubbles trapped in liquid and the break.
This one is a break.
Oh, okay. Okay, because gas can be compressed, right? So air bubbles are gases. So air bubbles are gases. Now for this thing to work properly, the person step here, the liquid will push and it will push the brake. Okay, the flow is like this. So can you imagine if there are air bubbles inside? So let's say I got air bubble inside here. When I have air bubble inside here, so this guy step on the brake. This thing try to push, but what happens is that instead of pushing the liquid, instead of pushing this pedal, the air bubbles get compressed. The air bubbles get compressed, so end up you don't get enough push here.
Yeah.
Right? So that's what the air bubbles do. They prevent the piston B from being pushed to the brake because they get compressed. The air bubbles get compressed instead of the piston.
Okay.
Can you see that? This why the answer is this. The air bubbles are compressed and piston B may not move.
May not move as much.
Yeah, correct. It may not move as much because, yeah, when you push this thing, instead of pushing the piston, the bubbles get compressed. What?
Compressed.
The bubbles get compressed, so you cannot push it in the direction.
Okay.
Yep. Next. All these are this year prelim, right?
Yeah.
Yeah, I went through with some of the students. I remember some of them, but most of them, okay, let me see. Answer 4, why not 3? Okay, so Jason wants to find out how the rate of photosynthesis was affected by the amount of light. Intensity. So it's about intensity. Place a plant, then record the number of bubbles. You have to make a change. Yeah. Which of the following are possible changes which Jason could make? He placed length 10 cm from the beaker. Then he recorded the number of bubbles. Oh, okay. So you see here, we are talking about what he can do to carry on with the experiment. To carry on. Now he has you cannot change the brightness, you know. You cannot change the brightness because your option you're not allowed to change the brightness. If you change the brightness, you will affect the intensity of the light. Yeah, in this question, you want to find out if the intensity will affect, right? So what you do is you increase the distance, right? So you put it further. So when you place it further, the intensity will have decreased. But if you go and increase the brightness, then you will cancel out this thing. B will cancel out C, right? So you cannot increase the brightness of the lamp. It will affect the experiment, right? Okay, so if you put it 20 cm, right, that's further, and then you put it nearer, then you can check like how many bubbles will come out.
So it should be 3, right?
Let me see, C, D. Increase the brightness. Yeah, if you increase the brightness, you would affect the experiment, right? Yeah, so that's why I choose C and D.
C and D,
yeah.
Okay.
But the answer is 4, is it?
Yeah.
Mm.
Answer 3.
But if you increase the brightness, okay, I think I know what they mean, right? This is like possible changes. So they are not doing it simultaneously, right? That means what they're trying to say is that one possibility, that means if you increase the brightness, you don't change the distance.
Oh.
Right? So that means they are not doing this together. That means they are not changing the brightness, place the beaker, and change the distance of the lamp together at the same time. They are doing it separately.
Then they can also have A, what?
Add more plants in the beaker. But if you add more plants, you wouldn't find out if it is the intensity, the amount of light. You need to change the amount of light. So it cannot be A. You cannot change the amount of plants.
Okay.
Yeah. So now I understand, right? So B, you can use B as well.
Okay.
Because they are not done simultaneously. They are not done at the same time.
Okay.
Yeah. All right. Next. Okay. So what is function of blood vessels that surround the outside? The blood vessels outside is just to supply oxygen and food to the heart,
to
the blood vessels.
to transport oxygen and food to the heart.
Yeah, the heart, because the heart is a muscle ma. The heart is a muscle by itself. So muscle will need food and oxygen, right?
Yeah.
So the blood vessels supply the food and oxygen to the muscle, which is the heart.
Oh.
It's not for, because for is pump blood to other parts of the body. The vessel cannot pump blood. Only the heart. No. The vessels cannot pump blood. Sorry, which one?
Option 4.
No.
By the artery.
No. Heart. Heart is the organ that pumps blood.
Oh.
Heart pumps blood. Artery is they carry oxygenated blood
Away from the heart.
Oxygenated blood. Artery.
Okay.
Yeah. Okay, is this okay?
Yeah, okay.
Next one.
This one is like math, this one is like
Yeah, mathematics.
Yeah, we want to know is there a faster way,
Okay, let me see. So this is that means AB equal to BC. A plus B equal to B plus C. Is this is D? Sorry, D.
A plus B equal to D plus C.
Yeah. Then here D plus A is heavier than B plus C. DA. Which of the following about the mass of the object? So D. Mass of A is equal to D. A equal to D. A equal to D. Wow, this is like a, this is what I mean by like IQ question. We gotta eliminate. Yeah, options. A is equal to D. A equal to D. Can we tell? A equal to D. A plus D is more than B plus C. Okay, faster way, let me see. Sometimes I add numbers. Yeah, sometimes just to try. Like for example, A plus B equal to D plus C. Then AC is lighter than DA. Is this A?
Sorry?
Is diagram 2, is that A?
B.
That's B here.
B, yeah.
Oh, okay, B. So BC is lighter than DA. BC. Lighter. So if A plus B must equal to D plus C, let's say this one looks like, I don't know, we can try. Let's say this is like 3.
So that means A is heavier than B.
A is heavier than B.
Yeah.
Wait, try. A, yeah, because A remain here, right? You can see A remain here. Then when you put D here, so D is heavier than B, correct?
Yeah.
So D is more than B. Then if I put C here and D here, if I put C here, D here, so A remain here again. So I put C, D remain here. C, so B is heavier than C, right? Can I deduce that? C is smaller than A. C is smaller than A. C is I don't have a shorter way, no, to do this.
Oh, don't have.
Yeah, then it's like you gotta do comparison one by one.
I see.
I don't have a shorter way. A plus B. In fact, I think it's quite tough. How did Andre deduce this?
No. We just this one is the answer.
Oh, this answer. Yeah, it's not. It's quite tough. A B equal to DC.
Oh no, very confusing.
Yeah. So this type of question is the question which I get asked a lot of time by students, you know. Like they always,
I don't my students.
yeah, they always ask me, how is this applied in real life? Yeah, I always have problem answering. Like how, do you do this in real life? Like when you're working, do you have to deduce this kind of thing? Yeah, so I always say that well, I don't. You know, you don't have to do that. But it's just to it's like a IQ question, something more like an IQ question for fun.
Yeah.
Yeah. Okay, let me see how to deduce this, right? A, B, B, C. So if I put the same, okay, so for sure, D is more than B. This one confirm. D is more than B. So if I were to put no, D A is more than B C.
But never mind lah. We skip this question.
Yeah, I can't deduce it. I don't know how to deduce.
Yeah.
Never mind.
Yeah. Okay. Never mind.
My IQ not so high, you see.
No.
Yeah. Okay, which objects did the electric current flow through when the switch was closed? Object B attracted D. B attracted D. Okay, so electric current from here it will pass through
Now, did they pass through which object?
B. Wait, B. Oh. Switch confirm, right? C also confirm. A and C confirm.
Yeah.
Right, electric current must pass through this. So A and C is confirmed. Now how about C and D? So which option have A and C? This one, this one, this one. C is a D is paperclip.
Electromagnet.
No, D is a paperclip. B is the nail. Right?
Yeah.
B is pointing the nail. Now,
Yeah. The nail.
yeah. So if you were to look at how the electron flow, electric current, how it flows, I use the red color. So electric current come here. No. Now, does it go through the nail? It doesn't. It actually goes through the wire.
Go through the wire around it.
Yeah, and then go this way, go through the switch, then it must pass through the paperclip, and then go back.
Oh.
Alright, so can you see that it does not pass through the nail, also don't pass through the paperclip.
I see.
Yeah, electric current doesn't go through that. So it's option 1.
Okay.
Yeah, A and C only.
Okay.
Next. Which one could develop the fruit after B S visited them? B, flower A. Let's start. Sigma ovary, okay. So develop the fruit. Develop the fruit. Flower D on plant U. Okay, so we know this one confirm cannot, right? This one also confirm cannot.
Yeah,
A and C because no ovary.
Yeah.
We want to have ovary.
Ovary.
Right, before it can become a fruit. So
B.
stigma.
B only.
BD. Eh? How about D? Which of the flower could develop the fruit after B? Then what's wrong with D? U. Pollen grains from plant T. Alamak. Okay, do you know what's the answer? I mean, do you know why is it 1?
Huh?
Like, do you know why is it 1? I mean, do you have any idea why the answer is 1?
Is it pollination by bee? Bee has to go inside.
The bee, yeah, the bee can go inside here as well. But the answer is very lame, though. The answer is a bit lame. Look, you gotta look at this. Look at this. B only pollen grain from T.
From plant T.
From T, plant T. So if B go into this one, can it pollinate plant U?
Why cannot?
Cannot, because the pollen grain is from plant T.
But they can what? Cross-pollination.
No, different plant. This different plant. This one could be like, I mean, there are different plants. This one maybe like papaya. Then this is like mango.
Oh, different, totally different one, huh?
Yeah, different plants. So the pollen grain from papaya cannot pollinate mango. Yeah, because I was wondering how come, because both have ovary, right? Yeah, both of them have ovary, so they can turn into a fruit.
Oh, so it's different type of plant.
Ah, different plants. So I was reading, then because it's only pollen grain from T.
Oh.
Yeah, so it cannot pollinate this. Right? So the answer is B. I mean, yeah, 1. Answer is 1. Only B can be pollinated.
We still have something.
Any more?
Any more? No more.
Oh, that's all. Okay. Yeah. So I got some questions. You still have some time left. I actually sent you an invitation to go the other side. Have you received it in your email?
Yeah.
Or you can just click on the this thing here, 3 lines. Right? Can you see the board? I think it's on PSLE Science 2017.
Yeah.
Can we go there?
2017.
Yeah, let's go there.
Okay.
Okay.